Our next section is entitled Solving Linear Equations. This should mostly be reviewed, but you might come across a couple of new things that you may not have seen, or a refresher of things you may have forgotten. So to start off, just like there's an order of operations for numbers, which is PEMDAS, which is parentheses, exponents, multiply, divide, add, subtract. There's also an order of operations for equations, to solve equations. Okay, now, in general, you can use this for most equations, for most linear equations. The order of operations is 1, you distribute. Second, you combine like terms. Third, you get all the variables on one side. Then you move all the constants on the other side. And then lastly, you either multiply or you divide. Okay, so distribute, combine like terms, move the variables to one side, move the constants to the other side, and you multiply or divide to isolate the variable. Okay, so let's see that in action. So here's an example of that. So your first example, we have 4x plus 3 times x minus 2 is equal to 18 minus x. Okay, let's work through this. So your first step is to distribute. Now distribution is when you have a parentheses and it's multiplied by a constant. So in this case, the x minus 2 is being multiplied by 3. So the first step is we're going to distribute the 3 to each side. Now you have to follow this order of operations. So before you distribute, we can't add anything. We can't add any like terms. So the distribution comes first, which means we're going to have 4x, 3 times x is 3x, 3 times negative 2 is negative 6, and that equals to 18 minus x. Okay, and that's done. Second step, combine like terms. Now what are like terms? So the equal sign, it splits up the equation into the left-hand side and the right-hand side. On any given side, if you have two terms that are like terms, you can add them. So in this case, we have 4x plus 3x. We can add this because these are like terms. And again, like terms are only terms on the same side of the equal sign. So we got 4x plus 3x, that's going to be 7x minus 6 equals to 18 minus x. Okay, so we did the second step. Third step is you move all the variables to one side. Now for equations, it doesn't matter which side you move it to. You can move the 7x to the right or the negative x to the left. Since it might be easier just to keep things positive, I'm going to move the negative x to the left side by adding it. And because it's negative x, we do the inverse operation and we add. Okay, so 7x plus x is 8x. You got minus 6 equals negative x, positive x, cancel each other out, gives you 18. Okay, then we're going to add 6 to both sides. You now move the constants to the other side. This is called a constant, by the way, because it doesn't have a variable attached to it. So it's always going to be 6. It's always going to be 18. 8x, x is a variable, so if x was 1, the value of this would be 8. If x was 2, that would be 16. If x was 3, that would be 24. So 8x, this value can change depending on what x is. With 6 and 18, these are always going to be, well, negative 6 and positive 18. So these are called constants because the value of those never change. So we get 8x equals to 24. Then if you divide by both sides by 8, we're going to get x equals to positive 3. Okay, now once you have an answer, you can always check it. This won't be required of you on a quiz or a test, but if you want to make sure you did it correctly, the best way to do that is to check. So how do you check? You go back to your original equation. You don't go back to like a simplified form because when you simplified, you may have made a mistake. So you always want to go back to the original equation. And every time you see an x, you're going to replace that with a 3. All right, so instead of 4x, we're going to get 4 times 3. Instead of x minus 2, we're going to get 3 minus 2. and instead of 18 minus x, we're going to get 18 minus 3. So every time we see an x, we're replacing that with what we got for x, which was 3. Okay, so this gives you 12. 3 minus 2 is 1, so this is going to be 3 times 1. And 18 minus 3 is 15. 3 times 1 is 3, so we get 12 plus 3, which is 15. And since 15 equals 15, a solution to any equation is a number that makes the left side equal to the right side. And so because 15 equals 15, this value of x equals 3 made the left side equal to the right side, which means x equals 3 is a solution, and our answer checked out. Okay, now let's do an example that is a little more complicated, has a few more steps to it. So the next example, here's what we have. We have 8 minus parentheses 3b plus 5. That equals to negative 5 minus 2 times b plus 1 plus 5b. Okay, kind of a long problem. But let's work through it step by step. Let's follow our order of operations. Our first step is to distribute. Okay, so I'm going to break this up into the left side and right side, and I'm going to work with the left side. So on the left side, we have 8 minus parentheses 3b plus 5. If there's a number at the front, there's an invisible 1. Okay, and we can't subtract the 8 and 1 because we're not combining like terms yet. You have to distribute before you can combine like terms. So the distribution is always going to take place first, which means this gives us 8 minus 1 times 3b is 3b, negative 1 times 5 is negative 5. Okay, on the right side, we have negative 5. That stays the way it is. We're going to distribute first. So if you have negative 2 times b, that's negative 2b. Negative 2 times 1, that's negative 2. And then we got plus 5b. Okay, so step 1 is done. We distributed it. Now let's combine our like terms. On each side of the equal sign splits out the equation into a left side and right side. If you have terms that are like terms, you have to add or subtract them. So in this case, we have 8 minus 5. So this will give me 3 minus 3b. On the right side, we have negative 5 minus 2. That's going to give me negative 7. I also have negative 2b plus 5b. That'll give me positive 3b. So these are also like terms. Okay, so the combining like terms, that is done. Now we have a choice. We move all the variables on one side. So we can either take the negative 3b, move that to the right, or take the positive 3b, move it to the left. So again, it's easier sometimes to keep things positive. So I'm going to add 3b to each side. And you could have done it the other way too. It would not have made a difference. So we're going to get 3 is equal to negative 7 plus 6b. Okay, now we're going to add 7 to each side. So 3 plus 7 is going to be 10 equals to 6b. And then if you divide everything by 6, you have to reduce every fraction. So if you reduce 10 divided by 6 by 2, you divide both the numerator and denominator by 2. And this will give you b is equal to 5 over 2. Okay, now let's go to the next part. So what happens if you have a rational equation? So first of all, a rational equation is an equation that has fractions. The ones that one or more of the terms is a fraction. So I'm going to get rid of all this. Okay, and here's your next example. Okay, so we have 5x over 6 minus 3 over 8, and that is equal to negative 7x over 4 plus 3. So here's the problem. We have a bunch of fractions. Okay, now we learned back in the day that when you're adding fractions, you need to get a common denominator, or if you're subtracting fractions, you need to get a common denominator. But when you have an equation, we don't have to do that. There's an easy way of doing this. We can just eliminate the fractions. Okay? We can get rid of the fractions. So, let's say to get rid of a fraction, to get rid of fractions in an equation, blank both sides by the blank. So what we're going to do is we are going to multiply both sides by the lowest common denominator. It's also called the LCD. Okay, we're going to multiply both sides by the lowest common denominator. By doing that, we eliminate all the fractions. Okay, so let's look at what the denominators are. We have 6, 8, and 4. Now, let's look at this term. It's the lowest common denominator. So a common denominator is a denominator that's common to all three of the fractions, or all three of the denominators, 6, 8, and 4. Okay, so for example, I can't pick 8 because 4 goes into 8, but 6 doesn't. So this has to be a number that 6, 8, and 4 can all go into. Okay, so in this case, our lowest common denominator, or in other words, our LCD, is going to be 24. 24 is the lowest number that 6, 8, and 4 can all go into. Okay, so we're going to multiply the left side by 24, and we are going to multiply the right side by 24. So to eliminate the fraction, we multiply both sides by the lowest common denominator. So here's what that looks like. You take 24 and you multiply it to 5x. So I'm just going to leave it like this. I'm going to say 24 times 5x divided by 6. Then the 24 is going to distribute to the 3 over 8. So we're going to get minus 24 times 3 all over 8. Okay, on the other side, the 24 is going to multiply to negative 7x over 4. So we have negative 7x times 24 over 4. And then here, we have the denominator, but the 24 is still going to distribute. So we're going to get 3 times 24. Okay, let's simplify this. By the way, notice that on this side, I put the 5x and the 3 in parentheses. On this side, I put the 24 in parentheses. Because it's multiplication, it doesn't matter which one you put in parentheses. But use parentheses to separate the two terms. Okay, let's simplify this. 6 goes into 24 4 times. 4 times 5 is going to be 20x. Now the reason this works is because the lowest common denominator is common to all the denominators. So because 6 can go into 24, the 6 goes away, turns into a 1. Same thing over here. The 8, it's going to go into 24 3 times. That's why the LCD works. Because whatever the LCD is, it's common to all three denominators. So we know that 8 is going to go into 24, which means 8 is going to cancel out. Okay, so 8 goes into 24 3 times, and 3 times 3 is 9. So we get 20x minus 9. Okay, on the other side, 4 and 24 can reduce. So 4 goes into 24 6 times. And negative 7x times 6 is going to be negative 42x. Now here, there's no denominator, it's just a 1. So 3 times 24, that's just going to be 72. By the way, this is a common mistake that I see my students make. Just because this doesn't have a denominator, it doesn't mean you don't distribute the 24. The 24 distributes to all terms, including the 3. So 24 times 3, this will give you a 72. Now we have no distribution, we have no like terms, so let's move all the variables to one side, the constants to the other side. So we're going to take 42x, and we're going to add it to both sides. Then we're going to take the 9, and we're going to add that to both sides. Because remember, we have to move the constants to the right. So we're going to move the 9 to the right. So this cancels. We're going to get 62x equals to 81, which means x is equal to 81 over 62. Okay, so the key here is, if you have a rational equation, one with fractions, you can eliminate the fractions by multiplying both sides by the LCD, the lowest common denominator. Okay, let's see one more example. Now for the next example, I encourage you to try this by yourself. So pause the video, try the next example by yourself, see if you can get it, and then you can resume the video to check your answer. Okay, so hopefully you guys paused the video and had a chance to work out the next problem, but here's what the problem says. We have x minus 3 over 5 plus 1 over 6, and that is going to equal to x plus 1 over 3 minus 9 over 10. All right, so first of all, what is our LCD? Between 5, 6, 3, and 10, you have to find a number that all of these can go into. So that number is going to be 30. 5, 6, 3, and 10, they can all go into 30. So we're going to multiply the left side by 30, and we're going to multiply the right side by 30, which is the lowest common denominator. So the 30 is going to distribute to both terms on the left side, as well as to both terms on the right side. Okay, on the left side, what's going on? So we got 30 times x minus 3 over 5. 30 times 1 over 6, that's going to be 30 times 1 all over 6. Okay, on the right side, we're multiplying 30 times x plus 1 all over 3. And then you got minus 30 times 9 all over 10. All right, let's reduce. 5 goes into 30 6 times. And now the 6 is going to distribute to the x and the negative 3. So this gives you 6x minus 18. 6 goes into 30 5 times. 5 times 1 is 5. On the right side, 3 goes into 30 10 times. So 10 times x, that's going to be 10x. 10 times 1 is going to be 10. 10 goes into 30 3 times, and then 3 times 9 is going to be 27. Okay, so all the fractions are gone. We distributed. Now let's combine like terms. On the left side, we've got negative 18 plus 5. So this will give us 6x minus 13. On the right side, we've got 10 minus 27. This will give us 10x minus 17. All the variables have to go on one side, so I'm going to subtract 6x. I just want to keep my x's positive. Then all the constants go on the other side, so I'm going to add 17. If I simplify that, I get 4 equals to 4x, which means x equals to 1. Okay, so on this section, think of questions you have. Write down things you didn't understand all that well. And when you guys come back to class next time, then come prepared with questions.